4, B, and B. Function for 4 looks like this. F of x equals x squared over x plus 1. And D wants the opposite of that. The opposite of my function. Well, we could just go the opposite of this function. Done. Yeah. Or you could put it in the top. Or you could put it in the bottom. It doesn't really matter where that negative goes, as long as it's only in one place. If you put it in the bottom, then you have to be careful. So I also would have accepted this. I also would have accepted this. Or if you distribute it. All 4 of those are acceptable. Right. E wants what? F of x minus 2. All right, so for this one, then I plug that into my function. So x minus 2 squared over x minus 2 plus 1. And I'm going to work that out. X minus 2 times x minus 2 over x minus 2 plus 1. That's x squared minus 4x plus 4 over x minus 1.
We're not trying to cancel these.
Hey, you hope. That would be great. But the chances of that happening are pretty slim. All right, 5. This was 5c and 5e. C. Well, let's get the function up here first. All right, C wants f of negative x. All right, so I plug a negative x everywhere in that I see an x. So I'm going negative x squared minus 4. What is negative x squared? Squared. Actually got back what I started with. And then E, which was this one again. So f of x minus 2. I want to plug that in everywhere I see an x. So I'm going to go x minus 2 squared minus 4. I'll do that square root. We already know that when I square that from the last problem, I'm going to get x squared minus 4x plus 4 minus 4. And those 4's cancel, so I did get a little bit cancel. That's what we got. That's 5c takes us to 9. Different section. This one just says find the domain of the function. Right. Remember that domain is everything that x is allowed to be. Sometimes easier to think of what is x not allowed to be. 3. Anything else? Negative 3, because this factors to x plus 3, x minus 3. So x is not allowed to be 3 or negative 3. All right, so as we're going left to right, which is the first one that's going to be a problem? Oh, and can x be everything else then? Yes, so we're going to go from negative infinity to negative 3. Then we're going to pick back up on the other side of negative 3 and go until which one will I hit now? 3. And then I'm going to pick up on the other side of 3 and go to infinity.
Which is that agree?
They didn't have this. What else? 13. Same section? Yes, it is. H of x equals the square root of x over the absolute value of x. Yes. And how do we write that? So x can't be negative because I'm not allowed to have negative underneath the square root. So how do I write that? greater than 0? Can it equal 0?
No.
Why not? Can I take the square root of 0? That's okay, but I'm not allowed to have 0 down here in the denominator. That takes care of that. All right, and then we can write that in the integral notation. So what is the smallest thing that x is allowed to be? Above 0, so not including 0 up until infinity. So these mean the same thing. All right. You're getting pretty good at domain. 15, same section. All right, we want to see if we can factor that denominator. I believe it does. Plus minus 3 and 1. So what is x not allowed to be? Okay, so it can be everything else, right? So from negative infinity until, which is the first one I'll hit, negative 3, and then I pick up on the other side and go to, then I pick up on the other side and go to, 17. Did you need to see all of the parts for this one?
No, I just need to see
Just the dividing one? Okay, so they want f over g of x. So that's 2 minus x over 3x plus 1. Can I cancel anything? Can I factor anything and then maybe cancel something? No. Good. 19e. I'm confused. Maybe I misunderstood that one.
I think, sorry, I think that was 21.
There is not an e.
Yeah, so I think it's 21.
Oh. You just want to see 21. All parts? Okay. This one's a little bit harder than the last one. Okay, so we want to divide these two functions. So f over g of x. So that's going to be f of x over g of x. Now, when you have a fraction divided by a fraction, what do you do with that? Multiply by the reciprocal. So I go x plus 1 over x minus 1 times x over 1. And that's going to get me x times x plus 1 over x minus 1. And if you want to distribute that through, you're allowed to do that too. Or if you want to leave it that way, I'm okay with that. $23. Okay, we're supposed to take this function and put it into this expression. Okay. So for the first part, that means everywhere I see an x, I'm supposed to put an x plus h in for it. So I'm going to have negative 2 times x plus h squared plus x plus h plus 1 minus all of this original function. That's why it's got to go in parentheses. I'm subtracting all of it, not just the first part. All right, and then we FOIL and distribute as best we can. Find like terms. So I have negative 2 times x plus h times x plus h plus an x plus h plus 1 plus 2x squared minus x minus 1 all over h. I already got some canceling because this x and that x goes. This 1 and that -1 goes. Still have to FOIL over here. So I'm going to get x squared plus 2xh plus h squared. I still have a plus h out there, and I still have a plus 2x squared out there, all over h. The last thing to do is distribute this -2 through. So I get a -2x squared minus 4xh minus 2h squared plus h plus 2x squared, all over h. I still get a little bit more canceling. This goes with that. I got -4xh minus 2h squared plus h all over h. What does everything in the top have in common? Yeah, they almost all have 2's, but they definitely all have h's. So I can pull that out, leaving me behind with a -4x minus 2h plus 1. And then these h's cancel. I'll be left with -4x minus 2h plus 1. Okay, and the last one here, 27D. Okay, 27. We've got a graph, and P wants whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. All right, so take a look at that graph. If I were to take everything on the left-hand side of that graph and flip it over the y-axis, would it lay right on top of what's over there on the other side? Nope. So it's not symmetric with respect to the y-axis. If I were to take everything at the bottom and move it to the top, flip it over, would it lay on top? Nope. How about, is there any way that I could get whatever's on one side of the graph flipped over the origin to lay on top of the other one? Nope. So it's not symmetric anyway. And I'm not going to ask you that on the test. E, whether the function is even, odd, or neither. Yeah, that's an interesting one. What do you think about that? Yeah, because we have a nice little test if we plug things in, right? Nope, we're 0. All right, so this is the one that we're looking at. So if things were even, odd, or neither, we could tell by plugging in -x and then seeing what we got out. So if we plugged in the opposite of what we started with, and we got out the same thing that we were supposed to get from the beginning, then it was even. If we got out the opposite of it, then it was odd. And if we didn't get out anything that made any sense, then it was neither. All right, so let's just look at this first point here. Right, if I plug in a -4, what do I get out in the normal function? 2. Okay. Now, if I plug in the opposite of that, which would be +4. If it's going to be odd, I would get out a -2. If it's going to be even, what would I get out? 2. What do I get out? 0. It's neither. You can tell by 1 point. This is neither. That makes sense to you guys? Yeah. It's either, if I give you one like that, it's going to be the function type, not the picture type. Any other questions?